Alrighty, well, welcome back. We're going to take our idea of scatter plots and kind of build upon what we started last week. So let me give you this example. And by the way, this is an example you're going to be doing in class today. You're going to be kind of building on this. So try to pay careful attention. Suppose you have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 students. You took, say, a sample of 8 students from a class, and you wanted to find out whether how well they did on one quiz relates to how well they do on a second quiz. And so what I have here are 8 students, just randomly selected. And I've recorded their quiz scores. So one student, for example, got a 2 on the first quiz and only got a 1 on the second quiz. Another student got a 1 on the first quiz but got a 3 on the second quiz. Another student, well, they got 3 on the first quiz and they also got 3 on the second quiz. There's a student over here who scored a 6 on the first quiz, and it looks like they scored about an 8 on the second quiz. So our question is there a relationship between how well somebody did on quiz 1 and how well they did on quiz number 2? So let's kind of go back to some things we've done recently. One is the cases. Okay, the cases would be the 8 students here that I selected. The variables would then be, well, quiz 1 score, that's a variable, and quiz 2 score is a second variable, and those are both measurement variables. They're not categorical. They're measurement or quantitative variables. Let's talk about some other things that we've looked at. The association. Well, if I look at this arrangement of dots, it seems to me to be a pretty strong, positive, and linear association. Now, some might argue and say, well, I think it's more moderate. This doesn't really look like a very tight formation of dots to me. So you could definitely make the argument that maybe it's a moderate, positive, and linear association. And then the trend, which means context, we're going to say, okay, well, the students who scored higher on quiz 1 tended to score higher on quiz 2. There's probably some exceptions to that. That's why I use the word tend to rather than all students who scored higher on quiz 1 scored higher on quiz 2. There's probably an exception or two to that trend. So we want to say tended to. So now what we're going to go from there. Oh, I'm sorry, I almost forgot. There are 2 other things that we talked about last week. Is there a generalization? Well, yeah, maybe if I had randomly sampled these 8 students from a class of, say, 30 students, I might be able to generalize this trend to all 30 students. Again, assuming that I had randomly picked the 8 kids from the class. The other thing is there cause and effect here? Does doing better on quiz 1, is that the cause or the reason why students did better on quiz number 2? And I would probably think no. I think there's a third variable. I think there's a lurking variable here. A lurking variable that's probably in control of both the quiz 1 and the quiz 2 variable. And for me, I would think, well, maybe it's their knowledge of the subject matter or their study habits. Those are probably factors that are kind of causing the relationship that we see between quiz 1 and quiz 2. More so, I don't think quiz 1 is causing quiz 2. I think it's probably study habits or maybe sleep or just sort of knowledge of the subject matter. Those are probably the kind of the root causes for what we see. Okay, so let's take that out of there. So now what we're going to do is we're going to try to be more specific about the relationship we see. And the way we do that with scatter plots is we draw what's called a line of best fit. So I'm going to try and basically draw a line that passes through the middle of the data. And so I'm just going to kind of, you could probably try different angles and such. I'm just going to try to settle on something right around, I'll go with that. So this is going to be my line of best fit. And I should probably say this is more like a line of good fit. It might not be the best line out there, but it looks pretty good to me. And so then we decide, well, how do they decide like which line is best, which line fits the data the best? And that's what we're going to look at today in this example right here. So first thing you need to do is I have to kind of come up with an equation for this line. So I'm going to kind of look at for my intercept. For me, it looks like about I don't know if I'm just guessing, about 1.8. And then I have to think about rise and run. So I don't know, maybe if I go like up 2 over 3, up 2 over, yeah, it looks I look pretty close to an up 2 over 3 ratio. So for me, my line has the equation y equals 2/3 x, and then I was estimating the intercept to be about a 1.8. So that's my line, and I should say my line of good fit. And I now want to see, well, how good is it? And so if somebody else draws a line, which in fact is what you're going to do later on after this video finishes, you're going to draw a line and see how it compares to mine. We got to decide whose is better. Which one fits the data better, would serve as a good predictor of the relationship between quiz 1 and quiz 2. So here's how we're going to make that decision. So I'm going to take my line to illustrate, and then later on you're going to take a line that you've made to see how well your line fits. So what you're going to do is you're going to set up a little table of values right here, and I'll walk you through these steps. But the first thing is, here are all the original points. 1, 3, which is right there. 2, 1, which is this point. 2, 4, which is this point. 3, 3, which is that, and so on. So you make a table of values. And then next to that, you set up what's called a prediction column. And this is based solely on the equation. The equation I went with, okay, is what I'm going to use to make predictions. So what I'm going to do is I'm going to plug 1 into my formula. So 2/3 plus 1.8. Let me do that on my calculator. I get about 2.47. So that would be the predicted y value. If I plug 1 into my equation, it's predicting a y value of 2.47. And then I take 2 and plug it in. So 2/3 times 2 plus 1.8. Let me put that into my calculator. 2/3 times 2 plus 1.8. I get about 3.13. Now if I plug 2 in, well, I just did that. 2 gets plugged in. I know this is going to be 3.13 again. And you'll have to round your answers a little bit. And then I'm going to plug 3 in. Now 3 is actually pretty easy. 3 times 2/3 is 2, plus 1.8 is 3.80. And then I already went ahead and plugged in the other ones just to save us all a little bit of time. I plugged in the 4s and 6s, and I got these for the predicted y values. So that's the first phase, is to create a table of predicted y values. Well, then you look next, you say, well, wait a minute, but it didn't turn out to be 2.47. It actually turned out to be 3. There's a little bit of what we call error. And you see error here as well. And that's because these dots aren't right on the line. There's a little bit of gap between the dots. For example, the 0.13, which is right here, okay, the line predicted an answer of 2.47, but the real answer is here. The 3 was a little bit of above, so there's a little bit of error right there between what really happens and what's predicted. And so too with the second point, 2, 1, which is here. Well, my line's saying the answer should be 3.13, and there's a little bit of error well, actually quite a bit of error right there. So each spot on the line is going to be off from the actual data point. And so we have to assess how much error do we have. And so to find error, what you're going to do is you're going to take what really happened for the y minus what your equation is predicting. So in this first case, I would do 3 minus 2.47, and I would get about a 0.53. And then I'd go to the next one. I'd say, well, okay, I've got a 1 minus 3.13 is negative 2.13. The next one, well, y should have been 4, but my prediction was 3.13. So 4 minus 3.13 is 0.87. And then, let's see, the last one here, 3 minus 3.8 would be negative 0.80. Okay, and so those are all the errors, and I went ahead and already did that for these other ones. I found out, take what really happened minus what you predicted to happen, and these are errors. And you'll notice that some of these errors are positive and some are negative, and that's because some of the dots are, well, some of the dots are above the line. There's 1, 2, 3, 4 positives, and there's 1, 2, 3, 4 negatives, and that corresponds with what I see right here. Now, if I take all my errors and just add them all up, okay, it looks like I don't have a lot of error, only 1.07. But you have to realize negatives and positives kind of cancel one another out. So we really don't use that to decide, you know, how well the line fits the data. By the way, we also call errors, sometimes call them residuals. So I'll use those words interchangeably. So here you have a list of residuals, and it's pretty easy to get the residuals to add up to something close to 0, just because there's always going to be some positive and negatives that cancel out. The way we're going to decide it actually is we're going to do what's called squared error. And we're going to take each of our error numbers and we're going to square them, multiply them by themselves. So if I take 0.53 times 0.53, I get about 0.28. And if I take 2.13 times itself, that's going to get me about 4.55. And then if I take my 0.87 and then I square that or multiply it by itself, I get about 0.75. And if I take 0.8, remember 8 times 8 is 64, so that's going to be 0.64. And earlier on I went ahead and did that for these other errors. I took all these errors and squared them, and I wrote down their squares right here. And so then what you do at the end is you add up all of your squared errors. And you now get this statistic right here, which we call SSE, or sum of squared errors. Okay? And so right now my line has an SSE of 14.14. And I wonder, is it possible, okay, can you come up with a line whose SSE will be lower than mine? If you do, your line fits the data better than mine does. Okay? On the other hand, if your SSE is larger than mine, then my line fits better than yours. And so what I'm going to ask each of you to now do is you're going to take out some paper and make this graph right here, these 8 dots, and then you're going to try and draw a line of best fit through those dots, and then go through and do this testing to see what your SSE is. Thanks for watching.